All right, welcome to This Explainer. I am absolutely thrilled you're here today because, well, we are tackling something that gives almost every developer a massive headache at some point. Yep, we are talking about Python concurrency. If you've ever felt like your code is just tripping over itself trying to multitask, or if just hearing the acronym GIL gives you night sweats, you are in the exact right place. Today, we're drawing directly from Aaron Rose's fantastic piece, The Secret Life of Python, to figure out how to seamlessly weave together threads, processes, and Asyncio without completely tearing your hair out. So, how do you make Python do three totally different things at exactly the same time? It's the ultimate concurrency question, isn't it? I mean, we've all been there, right? Struggling to balance these complex, competing tasks. You finally fix one bottleneck, and suddenly, bam, two more pop up, freezing your application and driving your users crazy. But the good news is there's actually a really elegant way out of this trap. To really wrap our heads around how to solve this, Aaron Rose sets up a brilliant narrative scene. I want you to picture a grand Victorian library in London. It's quiet, it's intensely focused, and code quality isn't just some nice-to-have goal. It is the unspoken objective. And it's here that we meet Timothy, a junior developer who is facing a massive architectural wall, and Margaret, his senior mentor, who deeply understands that true craftsmanship is really the only thing that matters in software design. Now, Timothy is totally stressed out. He's trying to keep a dozen processes spinning like plates on sticks. But Margaret stops him right in his tracks. She hands him an imaginary baton and delivers this total paradigm-shifting quote. She says, "You aren't a juggler anymore, you are a conductor." And that is exactly it. We need to stop treating our code like this frantic juggling act and start treating it as a beautifully orchestrated symphony. Okay, let's dive right into Section 1, the Grandmaster Tournament problem. Let's look at the seemingly impossible challenge Timothy was actually up against. He's built this massive chess tournament engine, and currently he has 5,000 live spectators. Think about that. That is 5,000 active, simultaneous network sockets relying on an engine that absolutely must remain perfectly responsive. Not a single microsecond of lag, no dropped connections. But here's the catch. Keeping those users happy is literally only a third of the battle. First, the engine needs to crunch some incredibly heavy math to analyze complex board positions. That is a deeply CPU-bound task. Second, it has to instantly talk to those 5,000 live users, which is a highly I/O-bound network task. And third, it has to safely save logs of every single move to a physical disk. And let's be honest, compared to a CPU cycle, writing to a disk is agonizingly slow. So you've got these three competing tasks fighting for the exact same resources. If the math blocks a main thread, the 5,000 users time out. If writing log stalls the system, the math stops crunching. It's basically a recipe for a total system crash. Which brings us to Section 2, Meet Your Python Orchestra. This is exactly where Margaret steps in to help. She categorizes Python's concurrency models not as these competing frameworks you have to choose between, but as three distinct instruments. First up, we have Asyncio. Margaret affectionately calls this the juggler. Asyncio is an incredibly efficient tool for managing thousands of web requests on a single CPU core, so it's absolutely perfect for handling Timothy's 5,000 live users. Why? Because Asyncio literally thrives on waiting. While one user's network connection is idle for even a fraction of a millisecond, Asyncio instantly swaps to another user, making sure the system never gets bogged down by network latency. It's fast, it's lightweight, and it is your absolute go-to for I/O. But Asyncio can't do the heavy lifting. That is where our second instrument comes in, the process pool. Think of this as the muscles. When you need raw CPU power, this is your guy. Now, Python has this infamous mechanism called the Global Interpreter Lock, or the GIL, which acts kind of like a bouncer. It actively stops Python from executing multiple threads of code at the exact same time. But a process pool completely bypasses this bouncer by spinning up entirely separate Python instances. For Timothy, this brute strength is exactly what he needs to crunch the heavy math of those complex chess positions in parallel, completely independently of whatever the network traffic is doing. And finally, we have threads, known as the helpers. These are your low-memory workers, ideal for handling simple waits like background logging and disk I/O. When Timothy needs to write a massive log file to that slow hard drive, a thread can just quietly take care of that chore in the background. Unlike processes, threads actually share memory, which makes them incredibly lightweight. They aren't going to stall the main application, and they definitely won't chew up the massive RAM overhead that full processes require. They are essentially the quiet stagehands keeping the whole show running behind the scenes. All right, moving into Section 3, the Unified Symphony Architecture. So now that we have our three distinct instruments, how do we actually make them play together without causing a totally chaotic racket? Well, Margaret explains that they are collaborators in a grand symphony hall. Respect the weight, utilize the muscle, maintain the flow. This is what she calls the secret of the specialist. See, the biggest mistake developers make is searching for a silver bullet, one single library that's going to magically solve every problem. But the truth is, there is no single best tool in Python concurrency. There is only the right tool for the right moment. When you map the correct tool to the specific task, all that infighting completely stops and your code cooperates beautifully. Let's make this actionable in section 4, Margaret's concurrency cheat sheet. Margaret actually gives us a really practical, actionable framework to pull this off. This simple matrix maps out the unified architecture perfectly, and it's something you can literally apply to your own code base today. You just match the tool to the use case and the persona. Got an I/O-bound network task like thousands of web requests? Call the juggler, Asyncio. Need to break the gill for intense math or, say, image processing? Call the muscles, your process pool. And if you're dealing with a slow, blocking disk write, like blogging, you call the helpers, your threads. It completely takes the guesswork out of the whole architecture. But to keep this symphony from falling out of tune and crashing the whole program, there are some pretty strict boundaries. Margaret lays out 3 non-negotiable final rules. Rule number 1, never ever block the juggler. If you are inside your Asyncio loop, you absolutely must offload heavy mathematical work to a thread or process. If you force the juggler to do math, he's going to drop all 5,000 balls. Rule number 2, respect the memory. Use threads for I/O to save RAM. Save your heavy processes for when you truly actually need that raw muscle. And rule 3, context managers are kings. Seriously, always use with statements in Python. It ensures your process pools and threads close properly and clean up after themselves, which prevents absolute nightmare scenarios like memory leaks. By following this exact architecture, Timothy watched his CPU cores light up with math, his threads quietly handle the disk I/O, and his Asyncio loops stay perfectly, beautifully responsive to all 5,000 users. He realized something pretty profound. Python isn't just some basic scripting language. It is a powerful tool for orchestrating reality. And as Margaret told him in her empowering final decree, the next time someone asks you how to make Python do 10 things at once, you won't give them a code snippet. You'll give them a symphony. Which leads us to our final thought for today. What symphony are you going to conduct next? Now that you understand how to seamlessly unite threads, processes, and Asyncio, you hold the baton. These tools are no longer a mystery. They are your orchestra, and they're just waiting for your command. I really hope this explainer has given you the clarity you need to tackle your next big project with absolute confidence. Thank you so much for joining me. Keep learning and happy coding.